Assalamu alaikum, dear students. I'm your teacher Gr11MS, and we are completing our lesson Limits and Continuity, Part1c. At the end of this video, you'll be able to find the limit of a rational function at infinity and find the limit of any function at infinity. But before we start, please try to prepare your textbook, your pens, draft papers, copybook, and your calculator. Limits of a rational function at infinity. Let p of x and q of x be two polynomial functions defined on the real set R as p of x is ax exponent n plus bxn minus 1 plus c, and q of x is a prime x exponent m plus b prime xm minus 1 plus into plus c prime, where a and a prime are two non-real zero numbers. A, b, c, a prime, b prime, and c prime are any real numbers. M and n are natural numbers. The limit of p of x over q of x as x tends to plus infinity will give us infinity over infinity, which is an indeterminate form by leading term method. And we can find that the limit of as x tends to plus or minus infinity of a xn over a prime xm equals to a over a prime if n equals to m, equals to 0 if n less than m, equals to plus or minus infinity if n is greater than m. Don't forget that c over any infinity plus or minus will give us 0 as c is any real number. Here is our example. Calculate each of the following limits. The limit as x tends to plus infinity of this rational function, 3x squared minus 2x plus 1 over 2x squared minus x minus 5, is plus infinity over plus infinity, which is an indeterminate form. By using leading term method, we'll get it's equal to the limit as x tends to plus infinity of 3x squared over 2x squared, which is the limit of 3 over 2 as x tends to plus infinity, which is 3 over 2. Another example, which is the limit of x cubed minus 1 over x4 plus 5x as x tends to plus infinity is a plus infinity over plus infinity, which is also an indeterminate form. Using the leading term method, we have it's equal to the limit as x tends to plus infinity of x cubed over x4, which is limit of 1 over x. As x tends to plus infinity, it will tend to 0. Also an example, the limit as x tends to minus infinity of x exponent 5 minus 3x plus 1 over x squared minus 7x is minus infinity over plus infinity. It's also an indeterminate form, which will be equal using leading term method, the limit of x5 over x squared as x tends to minus infinity, which is the limit of x cubed as x tends to minus infinity, which is minus infinity cubed, which will give us minus infinity. Here's your application. Find the following limits. Please pause the video each time you want to solve or to find the limit given. Here is a second application. A third one. Also pause the video to solve it. The last one. Pause the video to calculate it. Plus infinity into 1 over plus infinity will give us plus infinity times 0. Oops. an indeterminate form because plus or minus infinity times 0 is a plus or minus infinity times 1 over plus or minus infinity, which can be written as plus infinity or minus infinity over plus or minus infinity. So in this way we can get that this limit will be limit as x tends to plus infinity of 9x squared, which is plus infinity. Some remarks about limits. Let k and m be two strictly positive real numbers where k belongs to R and k is positive, m belongs to R and m is positive. In this application, please stop the video each time you want to solve to complete the table. The first table is by adding the terms. A new table, but this time we will subtract between the terms of the table. So pause the video to complete it. Complete with the new tables, but now we shall multiply the terms in the table. So pause the video again, please, to do. The last table by dividing the terms. Pause the video, please. Here we have 0 over 0. Pay attention, it's an indeterminate form and we'll see it later. A sum up of our period. First, 0 over plus or minus infinity will give us 0. L over plus or minus infinity will give us 0. A leading term method for polynomial functions. Also using leading term method to get these results about the rational function. Don't forget that we have 4 indeterminate form: infinity over infinity, plus infinity minus infinity, 0 times infinity, and 0 over 0, which will be seen later. Here is your assignment. Please revise the lesson, then do it. Coming next, how to find the limit of a function at a given point. See you soon, dear students. Thanks for listening.